Welcome back to another video by Adeptus Academy. Ever wondered what powers your phone or makes your remote control car zoom? That's the magic of electrical engineering. At its core, electrical engineering is about understanding and using electricity to make things work. Think of it as learning the secret language of gadgets we use every day. Electrical engineering is about designing pathways for electricity to do useful jobs. It's a world of creativity, problem-solving, and discovery. Our journey starts with one powerful idea, the circuit. A circuit is like a special road for electricity. By building these roads, you control where electricity goes and what it does. We'll break down the basics, explore components, and even build a simple project together. Ready to unlock the secrets of electricity? Let's get started. Let's dive into the heart of electronics, the circuit. Circuits are the invisible highways powering everything from your phone to your lights. But what exactly is a circuit? An electrical circuit is a closed loop that lets electricity flow, like a racetrack with no gaps. If the path is broken, the flow stops instantly. The main job of a circuit is to deliver energy to a load, like a light bulb or a motor. Without a load, the circuit has nowhere to send its energy. Think of a circuit like plumbing. The battery is the water company, wires are pipes, and the load is the faucet. If the pipe breaks, water, or electricity, can't reach its destination. Switches let you open or close the loop, controlling when electricity flows. Every circuit needs a power source, wires, and a load. Connect all three, and you've built the foundation of all electronics. Now, let's meet the main components of a circuit. These are the essential building blocks that make any electronic device work, from the simplest flashlight to the most complex computer. Understanding each part and how they interact is the first step to mastering electronics. Think of them as a team, each with a unique role: the power source, conductors, load, and switch. Just like players on a sports team, every component must do its job for the circuit to function properly. If one is missing or not working, the whole system can break down. The power source, like a battery, provides the energy needed to get things moving. It's the heart of the circuit, pumping electrical energy through the system so everything else can do its job. It has two terminals, positive and negative, creating voltage, which acts as the push that gets electrons flowing. This difference in charge is what drives the current through the circuit, much like water flowing from a higher point to a lower one. Conductors, usually copper wires, are the roads that connect everything together. They form the pathways that allow electricity to travel from one component to another, making sure the energy gets where it needs to go. Wires are coated in plastic or rubber to keep electricity on track and safe. This insulation prevents accidental shocks and stops the current from escaping, protecting both you and your project from harm. The load is the component that does the work, like lighting a bulb, spinning a motor, or powering a buzzer. Loads are what make circuits useful, turning electrical energy into something we can see, hear, or use. Loads convert electrical energy into light, sound, or motion. Whether it's a bright LED, a speaker playing music, or a fan spinning, the load is where the magic happens and energy is transformed into action. The switch is your control. Open it to stop the flow, close it to let electricity move. It acts like a gatekeeper, giving you the power to turn your circuit on or off whenever you want, making your project interactive and safe. When all these parts work together, you have a functional circuit. Each component relies on the others, and together they create a complete path for electricity to flow and do useful work. Miss one, and the circuit won't work. Even a single loose wire or missing battery can break the chain, stopping the flow of electricity and shutting everything down. These are the building blocks for every project you'll create. As you experiment and build more complex circuits, you'll see these same key players show up again and again, forming the foundation of all electronics. Get to know them. They're your new best friends in electronics. With a solid understanding of these components, you'll be ready to tackle any project and bring your ideas to life, one circuit at a time. Let's zoom in on the power source, the battery. Batteries store chemical energy and turn it into electrical energy. Inside, a reaction builds up electrons at the negative terminal, creating voltage. Think of it as electrical pressure. Higher voltage means more push for electrons. Connect a circuit and electrons flow from negative to positive, powering your devices. This flow continues until the battery's chemicals are used up. Always connect components with the correct polarity, positive to positive, negative to negative. Some parts, like LEDs, only work if connected the right way. Check for plus and minus signs to set up your circuit for success. The battery is where every circuit's journey begins. With power ready, we need a path. Conductors. Copper wires are the highways, wrapped in plastic for safety. The plastic is an insulator, keeping electricity where it belongs. Now, the destination, the load. Loads resist the flow, converting electrical energy into light, heat, or motion. In a light bulb, the filament glows. In a motor, electricity becomes movement. Every device has a load: TVs, toasters, speakers. Resistors are special loads that control current, protecting sensitive parts. Understanding loads helps you see what a circuit is designed to do. The combination of conductors and loads brings circuits to life. Every path has a purpose. Make sure yours is clear. That's how you turn electricity into action. Let's add control with a switch. In electronics, a switch lets you decide when electricity flows, just like flipping a light switch at home. When closed, current flows and your device works. Open it and everything stops. This simple control is the foundation for more complex systems. Switches come in many forms: toggles, buttons, sliders, each suited for different uses. Choosing the right one makes your project easier and more fun. LEDs, light-emitting diodes, are the stars of electronic illumination. They're efficient, colorful, and show when your circuit is working. LEDs only allow current one way, long leg to positive, short to negative. Get the direction right and they light up. Combine switches and LEDs to make interactive, bright circuits. Control the flow and see it in action. Time to build. Let's make a simple LED circuit. You'll need a 3V battery, wires or a breadboard, a switch, a resistor, and an LED. Start at the battery's positive terminal. Connect to the switch, then to the resistor. From the resistor, connect to the LED's long leg, a node. Connect the LED's short leg, cathode, back to the battery's negative terminal. Double-check your connections. Trace the path from positive to negative. With the switch off, finish connecting the battery. Flip the switch on. If all is well, your LED lights up. You've just built your first circuit and controlled electricity with a switch. This project brings all the core principles to life. Before you go, remember, safety first. Electricity is fun, but always respect it. Even small batteries can get hot or cause problems if short-circuited. Always double-check connections to avoid shorts. Disconnect power before changing your circuit. Work in a clean, dry, well-lit area. Never experiment with wall outlets. Stick to batteries unless supervised by an expert. Safety keeps your projects fun and your learning on track. Stay curious, keep building, and always put safety first. The world of electrical engineering is yours to explore.